So here we solve a problem on shear force and bending moment diagram. It was a previous year question for 15 marks. You can see the figure, that is one end is supported a fixed support, one end in the middle at point B there is a roller support, and there is a uniform distributed load of 100 pound force per inch and one point load of 1000 pound force at point C. So first we have to make the free body diagram. So for free body diagram, let us say that is point A, there is a support, that is RA. At point B there is also another support, that is point B. At point C there is a fixed load of 1000, point C, and this distance is 180 inch. There is a uniform distributed load, that is 100 per inch, and this is for 100 inch dimension. So that let us say that is point B and this is point E. So the distance point AD is not given, so we will consider that the load is acting at the midpoint of the AB. So we can say that this dimension is 180 minus 100, that is 80 by 2, that means 40, and this side is also 40. Okay. So for the shear force diagram, we have to first find out the reaction forces, that is RA and RB. To determine RA, we have to take the bending moment with respect to point B. So that is bending moment with respect to point B, that is RA into the distance, that is 180, and this will in clockwise direction. This load will act in counterclockwise direction, so minus this value, that is 100 for distance of 100 inch, and that we can consider that that is a point load at the midpoint, that is, so the distance will be 40 plus 50, that is 90, okay, and plus 50, that is 90, okay, and this load will, with the respect of this point, this load will move in clockwise direction. So plus 1000 into the distance is given as 60, 1000 into 60. So from here we can find RA is equal to 4666.67 lbf. You can cross check the value. So similarly we have to determine the force of RB. So for RB we have to take the moment with respect to point A, that is bending moment with respect to point A. By similar calculation we can find that RB is equal to 6333.33 pound force. So you can cross check the value of RA and RB by yourself. So we can write RA is equal to 4666.67 and RB is equal to 6333.33. It is pound force. So for shear force diagram, we know that for shear force diagram, the force at point A is we obtained as 4666.67. So it will be in positive direction if we consider, that is 4666.67. So that will be acted up to point D, that is for 40. So 40 inches, 40 inch, it will be at straight line. Then for uniformly distributed load, so the value of RD is similar, that is 466.67. For RE, with this load, the opposite direction load is the uniformly distributed load. So for F at point E, the value will be that force at D 66.67 minus the force by the uniformly distributed load. So the force is 100 into 100. So by calculating we can find the force of Fe is minus 5333.33 pound force. So this is point D, this is point A, and for point D the value is negative, that is minus 53. Let us assume this point E, that is minus 5333.33. So it will be like straight line up to this point. After that the value at B will be the force up to this point, okay, force up to this point minus the reaction force, because the reaction force is acting in opposite direction to the uniformly distributed load. So force at B point will be minus 5333.33 plus the force of the RB, that is 6333.33, that will be 1000 lbf, which should be equal to the last force for the cantilever beam. So that's why the system is in equilibrium. So up to this, from this point E, we have to draw a straight line up to point D, that is for 40 inches point B, and from point B we will draw a straight line up to 1000 lbf, and up to point C, that is also 1000 lbf. Okay. So let's draw the shear force diagram once again clearly. Let's say point A, this is point B, this is point E, B, and this is point C. So here the value is 466.67, straight line up to point D, and for point E the value is minus 5333.33, inclination up to point E, then up to straight line up to point B in the same value, and for point B it is 1000 for straight line, and up to point C. Okay. This is the shear force diagram. So now we have to calculate the bending moment diagram. Okay. Now the bending moment diagram. So we have to, for bending moment diagram, we have to start from one point. Let's say we start from point A. Okay. So with respect to point A, the moment will be 0, because the distance from point A to point A is 0. So the bending moment will be 0. So up to point D, then up to point D, okay, up to this point D. So that will be the force was equal to Fa. So that is Fa into the distance up to point D, that is 40, and Fa value is Fa value was 466.67 into 40, that equal to 18666.8. Okay, that will be pound force into inches. So you can cross check the value by yourself. All difficult. Now the moment up to point E. So moment up to point E will be this moment, that is Fa into the distance of AD, and for the uniform distributed load the force will be acting, the moment will be in opposite direction. So minus If we consider the load as a single load in the midpoint, so 100 into the distance, and for this distance was 90 by 2. So it will be around minus 26,333.2. And for up to B point, for MB we have to calculate the moment from this point, from point C. So that will be 1000 so minus 60,000. Now we have to draw the bending moment diagram. So at point A it is 0, and it will be straight line up to point D to the value of this value. Then up to point T, as it is uniformly distributed load, so the bending moment diagram will be in parabola shape for this point in negative value. So let's consider this as the ME value, and it will be like parabola shape. Then up to point MB that is minus 60,000 value. So this will be, if this is point B, this will be like this value, and for point C it will be 0. Okay. So you can recheck the values, there may be some calculation error, you can recheck the value and the diagram will be like this one.